Hi, this is Brittany Schmidke with Rigel Medical. Today we are going to be doing a demonstration, an electrical safety test using the Rigel SafeTest 50. First, let's look at the unit itself. On the bottom right-hand corner is where we're going to plug in the power for the SafeTest 50. Above that, we have two banana jacks. The black will be where your test lead, often called the Kelvin cable, will be plugged in, and the green one is where you would plug in your lead for the point-to-point testing. And then down and to the left will be the power cord for the device under testing. Okay, now we are going to apply power to the safe test. Look how quickly it pops up as soon as it's plugged in. We're also going to plug in our Kelvin cable, and we're also going to plug in the power source for the bed we're testing. Now you'll notice at top we have the 5 blue keys, F1 with the ohm sign. That's going to be for ground continuity testing. F2 with the microamp sign. That's going to be for testing your leakage, both your ground leakage and your chassis or touch leakage. F4 is going to be for your point-to-point testing. And F5 is simply the home key where you can set languages for display on the test. You'll see the 3 rectangular buttons beneath that. Green is going to be to turn on the unit. The red will be to turn off the unit. And the black is for reverse polarity. The 2 circular keys to the right. On the top, you have the ground key for open ground. Underneath that, you have the neutral key for open neutral. But do note that both the reverse polarity and the open neutral are for our global customers, and you do not need them to test to FPA 99 standards. Now, the SafeTest family does feature a universal voltage input, so it can be used at 120 volts, 208 volts, or 240 volts. Okay, so to start the testing process, you have to find a good ground point on the bed. We had previously found one next to the electrical box seen here. Now, it's very important to have a good ground connection or you're going to get false readings. Those false readings will usually show up as greater than 19.9 ohms. You also might have to scrape a little bit of paint off of a spot on the bed that won't be obviously seen. When you do have a strong connection, you might see a little bit of a spark. This is our zap circuit, ensuring there is no file resistance that could give you a bad reading. It's basically just decharging a capacitor. The NFPA 99 requirement for ground continuity is to be less than 0.5 ohms. So we're going to go ahead and push F1 with the ohm sign. And there you can see it is well within spec. Now we are going to press F2 with the microamp button, the green button to start it. And we now see the ground leakage value. Now we will press F3. And that is going to show your chassis or touch leakage. Now, normal operation is the limit is going to be 100 microamps. Now we're going to push the ground button to open ground. And this is actually the only single fault condition that is needed. And the single volt value is at 500 microamps. Now, the NFPA code also states that these tests need to be conducted with the power switch in the on and in the off conditions. You'll probably want to capture your test results on a form that's going to include the model and serial number of the device you're testing, the date of the testing, and the individual's name who conducted the test. Here, the F4, the VI button, is going to show you the current that the bed is pulling and the volts that are going into the SafeTest 50. We would like to thank Prius Healthcare in Oldsmar, Florida for allowing us to use their facility today. Thanks for taking the time to watch the video. Hopefully it was helpful. And you can always call our Tampa office at 813-886-2775 with any questions.